Good morning, dear students. All right, today we're supposed to discuss another small theory. And in another one class, I suppose we have another small theory. After that, doing some more sums to come to the end of this quadratic equation lesson. Right. People, as the first heading today, write down the next theory. From this theory part, the question repeated 3 times consecutively in 2007, 8, and 9. And this method is very helpful in getting the answers in a minimum number of steps of the questions coming under this. Right. So then the heading is, people, this write down the heading like this: to find the quadratic equation symmetric expressions involving roots of another equation. This is heading: to find the quadratic equation whose roots are symmetric expressions involving roots of another equation. Right. People, I'm going to first discuss this subheading by using a question, simple question. Right. Then we'll write one question like this. This is the question. Write down the roots x squared plus ax plus 1 equals 0 are alpha comma beta. Find the quadratic equation whose roots are alpha squared plus alpha beta and beta squared plus beta alpha. Very simple question. Alpha squared plus alpha beta and beta squared plus beta alpha. Right. Right, people, here we have to first understand what is really meant by these symmetric expressions. Right. Let's see what is meant by symmetric. People, now symmetric mean this. I'll take first these two roots given, alpha squared plus alpha beta and beta squared plus beta alpha. Right. If I take this alpha squared plus alpha beta and beta squared plus beta alpha. Right. People, take one root given here. You can very clearly understand in this expression there are two letters alpha beta. Right. Now I write like this, alpha, beta. Okay. Now people, what I do is this alpha in this expression, this alpha, right, we replace by beta. And this beta we replace by alpha. That means for every alpha, we write beta. For every beta, we write alpha. Where? In this given expression. Then see what happens. Beta squared, right? Here plus alpha is now beta. Beta is now alpha. Right. What I did, take in this given one root, it's the two letters alpha beta. I interchanged in the manner, for alpha I put beta, for beta I put alpha. Then this one converted to this one converted to this. People, this is nothing but the other root. This resulting one is the other root. Then people, we say the roots, this and this, are symmetric. Understand, people? So therefore, simply when we explain this, take one root, identify the number of different letters available. Usually people, there will be two, right? There will be two definitely, right? Then interchange that two letters between them. Taking one root, interchange the two letters like this. Taking one root, if we do so, as the result of that, if we get the other root, people, then we say that two roots are symmetric. Right. So then this theory I am going to, we can really, people, apply this theory for the roots having this property. For the roots having this property. Okay. For the roots having this property. Okay. The roots must be symmetric. Roots must be symmetric. Right. So now I'm going to work out this question, people. In the first method, we learned under theories we have done that. What is that? When we are given the roots, how to find the quadratic equation. We have done that now. Using that theory, I am going to first work out this question. That means the quadratic equation I am going to find by using that theory we already know. Secondly, I am going to tell you how to get the same answer using our second method. That method, people, you have to understand, and you should be able to use that. At the examination, people, usually some occasions you are given using that means using this method to get the answer. Otherwise, no marks. Right? Okay. So then, people, I am going to take the first method. Right? I'm going to use the first method to take this answer. Right? See how to use that first method. Then let's see then how to use the second method. Right? Then you can very clearly understand the given quadratic equation is this: x squared plus ax plus 1 equals 0. Its roots are alpha comma beta, right? You know. Then you can very clearly understand sum of the roots and product of the roots we can write. Sum of the roots going to be, people, what? Minus x coefficient divided by x squared coefficient. X squared coefficient is 1. This divided by 1. One change. Alpha beta product is, people, constant. This divided by x squared coefficient. Then x squared coefficient 1. 1 divided by 1. Alpha beta is 1. Right. Now we need what, people? The quadratic equation with the roots. The quadratic equation with the roots. Alpha squared plus alpha beta. And beta squared plus beta alpha. beta alpha means again alpha beta, no? Right. Then we have learned when we are given the roots, the way of writing the quadratic equation. People, when the two roots are given, how to write the quadratic equation? We learned that when we are given the two roots, we know how to write the quadratic equation. What is that, people? Yeah, x squared minus, within bracket, sum of the roots, right? Sum of the roots. First root is this, plus second root is this. Beta alpha, I write. Yeah, I can write. Within first bracket, we have sum of the roots times 6 plus, what is the people? Second, product of the roots. This multiplied by this. Alpha squared plus alpha beta. Times beta squared plus beta alpha, I write like this, equals 0. People, this is the way of writing the quadratic equation of the given roots. Now, what we need to do is, people, this alpha beta terms we have to eliminate by using these two relations, right? That's what we have to do. Then what I do is this. Here is alpha beta and this beta alpha. Beta alpha is same as alpha beta, no? Then here we have alpha beta. Here we have alpha beta. Then we have x squared within bracket alpha squared, alpha beta plus beta alpha means another alpha beta, no? 2 alpha beta plus beta squared times 6. Right. Now we multiply this and this. What do you get? Alpha squared into beta squared. Alpha squared into beta squared mean, people, alpha beta squared. And this when you multiply, people, what do you get? Alpha squared into beta alpha. This alpha squared and this alpha cube beta. Right. Next one here, people, this and this. Alpha beta beta squared. Beta and beta squared, beta cube. Alpha beta cube. And people, this and this. Alpha squared. Beta beta squared. Alpha squared beta squared. Alpha squared beta squared, people, you know what is that really? Alpha beta squared, no? Equals 0. This way. Okay, right. Now, people, what is this really? You know the expansion of a plus b to power 2? It is a squared plus 2 times product of these two plus b squared, right? Then similar thing here we have alpha squared plus 2 alpha beta plus beta squared. So then I can write this one. What, people? Alpha plus beta perfect square, this trinomial, no? Times 6. Here you can see alpha beta squared and alpha beta squared. That is like x squared plus x squared. It is 2x squared. Like that here, alpha beta squared plus alpha beta squared means, people, 2 times alpha beta perfect square. Right. And from these two terms, people, we can take alpha beta product is common. Alpha beta product is common. Once you take alpha and beta, right? This beta, when you take here, we have only alpha cube. One alpha also from this alpha cube, when you take another alpha squared, comes within bracket plus. Here, we take alpha out. From this beta cube, we take another beta, then another beta squared is there, right? Equals 0. Right. Okay. I think up to here you can very clearly understand. Now, people, I can substitute This alpha squared plus beta squared, I can write like this. Right? Alpha beta. People, can you remember the way of writing this alpha squared plus beta squared? It is alpha plus beta perfect squared minus 2 alpha beta. No? Alpha plus beta perfect squared minus 2 alpha beta is equal to 0. Yeah. Now what we do is we substitute for alpha plus beta and alpha beta. Alpha plus beta is minus c, alpha beta is 1. Right. And then we will substitute that. X squared minus alpha plus beta, it's minus c, and then minus c perfect square. No, minus c perfect square times x. Here alpha beta is 1, 2 into 1 squared. Here alpha beta, also people 1. Right. Alpha plus beta perfect squared minus c perfect squared. Minus c perfect squared and minus 2 times alpha beta product is people 1. Equals 0. Right. Now we'll simplify. Minus a perfect squared mean people what? Minus a perfect squared is a squared, no? Then here we get x squared minus this minus I wrote here, minus a perfect squared is a squared x. 1 squared is 1, 1 into this 2 make people 2. And here when you multiply this bracket by this one change, minus c perfect squared is people plus c squared, and here we have minus 2 equals 0. Then you can cancel down this 2 and this 2. There we get the equation as this. Right? This is the quadratic equation. People, with the roots alpha squared plus alpha beta and beta squared plus beta alpha. Right? This equation has the roots this and this. Now see here, we had to simplify this way, a little bit long process. Okay, and this is our first method. This method we know already. At the very beginning of this lesson, we learned this. Right. Now people, let's see what is the other method. What is the other method? Right. Okay. Right. First come up to this. Take this. Then our required equation is what people? This one, right? X squared minus a squared x plus a squared equals 0. This is the required quadratic equation, right? Whose roots are alpha squared plus alpha beta, beta squared plus alpha beta. These two are the roots, right? Okay. Now, people, I am going to tell you how to take this quadratic equation without following this process. Okay. Yeah. Okay. So then, people, I am going to erase this part. I'm going to erase this part. Right. Second method, that is a method we supposed to discuss here, right? Okay, people, now second method, right? The second method is this, people. We need to find the quadratic equation whose roots are this and this. Right. Then people take any root out of these two you like. Whichever the root you take, never mind, because the two roots are symmetric in this case here. Symmetric. The two roots are symmetric. Due to the roots are symmetric, people, any root you can take. I take this root. All right, let alpha squared plus alpha beta. I take this root, people. I am going to name as y. Let y equals alpha squared plus alpha beta. Understand? Then I can take, people, alpha out. Alpha is common now for this. Once you take alpha out, what do you get within bracket is alpha plus beta. Right? Now for this alpha plus beta, you can substitute by this. What is alpha plus beta? Minus a. Then minus a alpha we get. Okay. Now this alpha is the root of this equation. That alpha I am going to subject in terms of this y. Then once you subject this alpha, we have divided this y by minus a. Right. This gives us alpha is equal to y divided by minus a. That minus sign comes here. Okay. Then let's turn again and see what have we done up to here. People, out of that two symmetric roots, we take any root we like. Any root you can take as y. Then using that root we took as y, people, this way one root of the very first equation given we have to subject. Taking this as y, simplifying. In some other question, people, when the roots will different from these expressions, the right hand side simplification will be different. Anyhow, people, using the letter y, we have to subject a root of the very first equation we had been given. That is the first step of this method. Okay. Out of that two symmetric roots, take any root you like as y. Then what do we subject? People, we subject in terms of y. In terms of y, one root of the very first equation in the question we are given. And then, people, I have subjected alpha in terms of y. In terms of y means in that expression, y letter should be available. Yeah. Now what we do is this, people. This alpha is a root of this, no? You know, people, when something is a root of particular quadratic equation, then that root should satisfy that quadratic equation. What is meant by the satisfying the quadratic equation? That root, when you substitute for every x, understand, in the left hand side of this equation, the simplified answer should be equal to right hand side 0. That is called as the root satisfies the quadratic equation. Understood? So now we can start from there. You can now write, since alpha is a root of x squared plus ax plus 1 equals 0, alpha must satisfy this. alpha squared plus substitute for x alpha, a alpha plus 1 equals 0. Right. But for this alpha people, we substitute what this minus y by a. Right. Minus y divided by a. Plus 1 equals 0. Now simplify here. Minus squared is plus y squared divided by a squared. Here plus and minus minus. When you remove the bracket, this and this a will cancel off. Then we get minus y plus 1 equals 0. Right. Now we multiply this equation by a squared. Left hand side these 3 terms and the right hand side 0, we multiply by this a squared. Then what do you get? When you write a squared here, that multiply a squared, then this will cancel off and give in only y squared. When you write this a squared before this y should be multiplied by a squared, then we get a squared y. And this 1, when you multiply by a squared, we get 1 into a squared, this a squared. When you multiply this right hand side 0 by a squared people, when you multiply something by 0, answer is 0. This is 0. Then people here, for the letter simple y, I write letter simple x. Then you can write in simple x for y. Now see what you get. See what you get, people. This y now x squared. Only thing is we write people for the letter y is x squared minus a squared x plus a squared equals 0. This way we get something. What are that, people? That is nothing but this, no? Right. So therefore, people, this is the method. Now, though you keep in terms of y, you see, it is correct, people. It is correct. Really, if we keep this equation as our required equation, it's correct. Only thing is, people, here we have letter y, but here we have the same thing in terms of letter x. People, usually when we write a quadratic equation or any equation, we use x, no. It is not compulsory to use always this x. We are familiar using this x from our smaller grades. People, x is the popular letter when you write an equation, but it is not a rule to use always that x as our letter. Any letter we can use. So therefore, people, though you keep in terms of y, it's correct. But I wrote simple x for this y because seeing something in x, of course, people, very familiar to us. So therefore, writing simple x for this y, we got this. This is the required equation. Well, that is a method then. That is a method. So then if you summarize this method again, people, you can very easily summarize this way. First of all, you have to check whether the 2 roots given are symmetric. For this, what you need to do, identify the 2 different letters available in each root and exchange between them. Right? For alpha, we put beta. For beta, we put alpha, taking one root. Selecting one root, if we exchange between alpha and beta, between the 2 letters available, soon after changing like that, if you get the new expression as the other remaining root, then we call that 2 roots are symmetric. Yeah. Then, so at the second step, take any root you like as y. Then, in terms of y, we subject people a root of the very first equation in the question you are given, in terms of why we subject that. Now that subjected one is a root of the given equation. So therefore, that given equation is satisfied by that root. So therefore, in the given equation for every x, that subjected root in terms of y, we substitute like this. Then finally, you get a quadratic equation in y. That is the quadratic equation we need. If you need, you can write simple x for this y and final equation we can keep in simple x. But that is not compulsory. If you keep the equation in terms of y, that's also accepted, that is correct. People, this is the method. This is the method of getting this answer. Right? Yeah. Now, right, people, we come to the another question in the tut. Right? Right. Question number 71, I take. As the next question in the tutorial. I think you have this question number 71. Read, people, question number 71. Read question number 71. I'll give 2-3 minutes. Just try this question. Thereafter, I'll work out this question. People using this method, second method, try to get this answer of question number 71 in the tutorial. Question number 71. Question number 71 in the tutorial. Okay. I'll give 2-3 minutes. Hurry up, people. Right. People, the question number 71 in the tut gives something like this. Alpha and beta are the roots of the equation x squared plus bx plus c equals 0. Right. X squared plus bx plus c equals 0. This is the quadratic equation. We are given its roots as people alpha and beta. The roots of this equation are alpha and beta. Here we are given furthermore that c not equal to 0. C not equal to 0. Right. Find the quadratic equation in terms of b and c whose roots are alpha cube, beta squared, and alpha squared, beta cube. We need to find the quadratic equation. This and this, these two are as its roots. Right? People, now when you take this root, it contains two letters alpha, beta. Then I interchange them like this. For alpha, we put beta. For beta, we put alpha. Then see what happens to this. This alpha becomes beta. Then this is beta cube. Right? And this beta is now alpha. Then this is alpha squared. Then this root converted to this beta cube alpha squared. Beta cube alpha squared means, people, this the other root. That means these two roots are symmetric. These two roots are symmetric. And then, people, the method we studied earlier can be used here. Can be used here. Right. Okay. So then I'm going to then first write, people, here. Alpha, beta are the roots of this equation. Then you can write alpha plus beta and alpha beta. Right. Okay. Alpha plus beta going to be minus b divided by x minus x coefficient divided by x squared coefficient. X squared coefficient 1, no? When you divide something by 1, it won't change. And the alpha beta product is the constant divided by x squared coefficient. X squared coefficient is 1, no? Then this is c, right? Now, the two roots given are people this alpha cube beta squared and alpha squared beta cube. Okay. Then I take any root out of these two as y. Take like this. Let y equals alpha cube beta squared. Then I write here y. Then this one I can write alpha cube. I can write alpha times alpha squared beta squared. Okay. Correct, no? Alpha cube I can write as alpha into alpha squared, no? Then we can write y equals alpha times this alpha squared beta squared I can write as alpha beta squared. But people, alpha beta means this c. We can put here c. Y equals alpha times c squared. Now in terms of y, I have to subject this alpha because alpha is a root of this given equation. Okay. Then once you bring this c squared to left hand side denominator, y divided by c squared equals alpha. That gives us alpha is equal to y divided by c squared. Y divided by c squared is alpha. Up to it's correct. Now this alpha is a root of this equation. Okay. Therefore, this alpha should satisfy what this equation. Then you can write after this, since alpha is a root of x squared plus bx plus c equals 0, right? We can substitute for this x alpha squared plus b alpha plus c equals 0. Now for this alpha, I substitute y divided by c squared. Right. Substitute for this alpha, y divided by c squared, y divided by c squared of x squared plus b, y divided by c squared plus c equals 0. Right. I will simplify this, people. We get y squared here. C squared means c to the power 4. And here, what do you get? By divided by c squared plus c equals 0. Now we'll multiply this by, people, c to the power 4. This term, this term, this term in the left hand side and right hand side 0. We multiply by, people, c to the power 4. Then what do you get there? This c to the power 4, when you write before this term, that and this will cancel off, giving only y squared. This c to the power 4, when you write before this term, c to the power 4 here, c squared here. Then c to the power 4 and c squared, when you simplify, c squared come into this place. Okay. Then b c squared y. B c squared y. And when you write here c to the power 4, c to the power 4 into c is c to the power 5 equals 0. People, though you keep like this, never mind, but we'll write for this y simple x, right? Yeah. Then we get the required quadratic equation like this. Therefore, the equation required is, right? Right, for this y x squared plus bc squared x plus c to the power 5 equals 0. Right. Okay, people. What equation? The roots alpha cube beta squared and alpha squared beta cube. The quadratic equation with the roots this and this is this, right? Then roots of this equation, what, people? Alpha cube beta squared and alpha squared beta cube. Okay. This equation has the two roots, this and this. Or in other words, the quadratic equation, this and this as the roots is this. Okay, right. Now, people, in the question, we have another part. What is that? Okay. Hence find. Okay. Hence find the quadratic equation in terms of B and C whose roots are given two expressions. Another one given. Then the last roots given, alpha cube beta squared plus 1 upon alpha squared beta cube is one root given. The other one is alpha squared beta cube plus 1 upon alpha cube beta squared. Is people, these two roots also symmetric. Symmetric. Now take this root and change in this way. For alpha, put beta. For beta, put alpha. Right. Take this. Here now this is beta. Beta cube alpha squared plus 1 upon beta squared alpha cube. This one now change to this. What is this? Beta cube alpha squared here. Alpha squared beta cube plus 1 upon alpha cube beta squared here. This is coming. Therefore, these two roots also, people, symmetric now. Symmetric. Therefore, in finding the quadratic equation, this and this as its root, people, the method we studied today we can use. Then what's the method, people? Any expression here, they are the roots, no? Take as y. Right? Take as y. Okay, then I am going to take this as y. Let y equals alpha cube beta squared plus 1 upon alpha squared beta cube. We take like this. Okay. Then we have the subject. Now we have to use this result now, people. Hence means that we are given in the question, you can see there is a word hence. People, whenever we have the word hence, right? You know, definitely the previous part we have to use. The previous part of the question is now this. What is this? The quadratic equation, this and this as its root is this. That story we have to use to take the next answer. That's the meaning of hence. Then we have to subject in terms of y, either this root or this root. Understand? Then before subjecting this or this in terms of y by this, people, we simplify this little bit. You know, here we have 1. Then I take the common denominator for this 1 and this as what? The product of 1 and this. Then the common denominator going to be 1 times this means this, no? We can simplify like that. Then we get alpha squared beta cube. By this, we multiply this. Then what do you get? Alpha cube beta squared into alpha squared beta cube. Then we get alpha cube alpha squared is alpha 5. Beta squared beta cube is beta 5. That's what we get when you multiply. Alpha 5 into beta 5 means alpha beta to the power 5. Here, right? Plus 1. Now, people, what is alpha beta product? Alpha beta is this C. Here, this now C to the power 5. Divided by alpha squared beta cube. Now, we said we need to subject this or this in terms of y. But alpha squared beta cube, this one here we have. That one only now we have subject in terms of y. To subject this alpha squared beta cube, people, what I do is this. I bring this part to here. and this y to here. Understand? Thereby you can subject this alpha squared beta cube in terms of y, right? Then we'll come to that. Right. If I write that here, I can subject that here. Then we get that implies what? Alpha squared beta cube is equal to c to power 5 plus 1 divided by y, like this. Okay. Now this one is a root. This is a root of this equation, no people. Then since this is a root of this equation, right? When you substitute this alpha squared beta cube for every x here and here, this equation must be satisfied by this. Why? This is a root of this equation. Okay. Then we write, I'll take this one, people. Okay, I write that like this. Since alpha squared beta cube is a root of x squared plus bc squared x plus c to power 5 equals 0, right? We can now write what, people? We can now write, substitute in for this x alpha squared beta cube. Alpha squared beta cube, we substitute for this its perfect square plus bc squared x alpha squared beta cube plus c to power 5 equals 0. This we get. Now what we do, people? For this alpha squared beta cube, we substitute this part in terms of y and keep simplifying. Then obtain quadratic equation in y. Write x for this y. Then you get the required quadratic equation. Right. You get this required quadratic equation by that simplification. Then what do you get? For this I substitute this c to power 5 plus 1 divided by y. Plus bc squared times alpha squared beta cube is c5 plus 1 divided by y, right? And last one is c to power 5 is equal to 0. Now we will simplify this. The perfect square of this fraction, no, then we have to square the numerator as well as the denominator. Then we get c5 plus 1 perfect squared divided by y squared bc squared c5 plus 1 divided by y c5 to the power 5, 0. Now people multiply this by y squared. Then once I write this y squared in multiplying this before this term, this y squared, then this will cancel off. Then we get c to the power 5 plus 1 perfect squared. And this y squared we write here. 1y of that we can cancel down with this y. Another y is here. Then we get bc squared c to the power 5 plus 1 times y. Right now, people, here, when we multiply this by y squared, what we get? We get c to the power 5 times y squared equals 0. Then write in for this y, simple x letter, we can write the required quadratic equation. Write in square term first and First power x term secondly and constant thirdly. Okay. Then we can write therefore the required quadratic equation is, right, here we write x squared c5 x squared. First we write c5 x squared plus this one bc squared c5 plus 1 x, and this is c5 plus 1 squared equals 0, people. This is how we take that answer. This is how we take that answer, right? And people will do another one question from this kind. The next question is 79 in the tute. Question number 79 in the tute. Right. People, again, I'll give you 5 minutes. 5 minutes. Try to get this answer 79. Take this 79. Finished. Okay, we'll see 79. The question given like this. Alpha and beta are the roots of the equation. This x squared plus bx plus c equals 0. Right. X squared plus bx plus c equals 0. Its roots are alpha, beta. Then people, we can write sum of the roots alpha plus beta and product of the roots alpha, beta. Sum of the roots going to be minus x coefficient divided by x squared coefficient 1. No, then this is minus b and alpha, beta, c. Correct. Okay, no. Now asking this, find the quadratic equation in terms of b and c whose roots are alpha cube and beta cube. Alpha cube and beta cube. And now people, we can write equation with the roots alpha cube and beta cube like this. Equation with the roots alpha cube and beta cube. We can write how, people? X squared minus, within bracket, sum of the roots times x plus alpha cube into beta cube, product of the roots. X squared minus sum of the roots times x plus product of the roots equals 0. People, can you remember this alpha cube plus beta cube? In the theory part, we did. What is this alpha cube plus beta cube? Alpha cube plus beta cube. We can factorize these, people. How? This is sum of two cubes, no? Then first ignore this powers 3. Then what do you get? Alpha plus beta, the first factor. What is second factor? How to obtain second factor? Yeah, we said using this first factor, we can write the 3 terms in the second factor. Square the first one, alpha squared. Take a sign to opposite minus. Product of these two, alpha beta, and square of the second one, beta squared. Then you can remember we wrote this alpha squared plus beta squared together minus alpha beta, and after that, people, you can remember this alpha squared plus beta squared we wrote. Alpha squared plus beta squared we wrote. Alpha squared plus beta squared we can write, people, how? Alpha plus beta perfect squared minus 2 alpha beta. You can remember that. And this minus alpha beta. And then I can write this alpha cube plus beta cube now this way, alpha plus beta times alpha plus beta perfect squared minus 2 alpha beta minus alpha beta is minus 3 alpha beta. Then I can write for this alpha cube plus beta cube. That expression. We people wrote that. Okay. We wrote that. Okay. Right. People, yeah. Then I can write x squared minus, right? Alpha cube plus beta cube is now alpha plus beta times alpha plus beta perfect squared minus 3 alpha beta times 6 plus alpha beta cube is this alpha cube beta cube equals 0, right? Now we can write x squared minus, right, people. Now alpha plus beta we can write minus b, and within bracket alpha plus beta squared, that means minus b squared minus 3 times alpha beta is c times 6. Alpha beta cube means c cube, like this. Okay, then here we get minus and minus make plus squared plus b minus b perfect squared is b squared minus 3c times 6 plus c cube equals 0, right? So this is the people quadratic equation with the roots alpha cube and beta cube. This has the roots alpha cube and beta cube. Okay, right. Right. Now people ask in next one, what's that? Hence find the quadratic equation in terms of b and c whose roots are alpha cube plus 1 upon beta cube and beta cube plus 1 upon alpha cube, right? Yeah. Hence means people definitely using this result equation. Okay, they will take that. Right. Yeah. First thing is alpha cube plus 1 upon beta cube, beta cube plus 1 upon alpha cube. This. Okay. People, these two roots are symmetric roots. You can very easily notice here when we interchange alpha and beta between them, by one root we can obtain the other root. That is why we say these two roots are symmetric. Then we have to take any root there as y. Let y equals alpha cube plus 1 upon beta cube. Y equals, here take alpha cube has denominator 1, no people. Take here common denominator as beta cube. Then this beta cube comes here and alpha cube beta cube coming plus 1. If alpha cube beta cube means alpha beta cube. Alpha beta to the power 3 is the meaning of alpha cube beta cube. Alpha beta is c. Then alpha cube beta cube means people c cube. C cube plus 1 divided by beta cube. Now we subject this beta cube in terms of this y. How? We use the cross multiplication, this beta cube to here, y here. Then we get, by this we get beta cube is equal to c to the power 3 plus 1 divided by y. Okay. Now people, this equation, when you consider, its roots are alpha cube and beta cube. Since beta cube is the root of this equation, that beta cube should satisfy this equation. That means when you substitute that beta cube for every x here and here, the simplified answer, left hand side answer should be equal to 0. Then we use that fact. Okay. Now you can write, since beta cube is a root of x squared plus b times b squared minus 3c times x plus c cube equals 0. We can put for x what beta cube. Beta cube of x squared b times b squared minus 3c beta cube plus c cube equals 0. C cube equals 0. Right. Our beta cube is people this now. Put that here. Right. Substitute for beta cube. What is that? C cube plus 1 divided by y is the beta cube. It's perfect squared. Plus b times b squared minus 3c. Beta cube is this. C cube plus 1 divided by y plus c cube equals 0. Right? Now we'll square this, the numerator and denominator both. C cube plus 1 perfect squared divided by y squared. B times b squared minus 3c c cube plus 1 divided by y plus c cube equals 0. Then people multiply this by y squared. When you multiply this left hand side 3 terms by y squared, this y squared we can cancel down with this y squared. When you multiply here y squared, when you write 1y we can cancel with this, only 1y come in here. This will be c cube y squared. Then we get, I write this one people first, c cube plus 1 perfect squared plus b times b squared minus 3c times c cube plus 1. When I multiply here y squared, 1y later we can cancel down with this y. The other y later will be remaining here, but I write that end of this. Plus c cube y squared equals 0. Now people, we can write for the simple y, simple x later, and write in first x squared, then x and others equals 0. We get the required quadratic equation, right? So therefore, required equation you can write c cube x squared, right? And next I write this b times b squared minus 3c c cube plus 1 x plus c cube plus 1 squared equals 0 is the required quadratic equation. Is the required equation. Is the required equation. This is how people we take that answer. Okay, from that theory people, some more questions available, right? Do those questions as homework, right? Right. We will ask the next question today. I suppose to take the question number 78. A similar question was in the paper, right? A similar question was in the paper, right? Question number 78 is the next. Right, take question number 78. and read the question, people. I'll give you 5 minutes again. Just try this question. Number 78. Right, our new group, very near future, people will start. Those who are willing to join the class, please put a WhatsApp message, mention your name and your WhatsApp number and school to my number. To this number, put a WhatsApp message, mention your name and your WhatsApp number and your school. Right, so then I will make the group, and then before the class, 1 week before the class, I'll send you a message regarding the details of the classes, the time and the lesson we start from. Okay, if you have friends, they are willing to join, please give this number and ask them to send a WhatsApp message, mention their name, school, all right, and WhatsApp number. Okay, right, now read this question, people. There is a particular long simplification, right? Let's see what's that. Yeah, you're given fx equals x squared plus bx plus c, and gx x squared plus qx plus r. B, C, Q are real numbers, C not equal to R. Alpha, beta be the roots of gx equals 0. Right. Gx equals 0. Gx equals 0. Gx equals 0 mean, people, gx is this, no? X squared plus qx plus r equals 0. This is the gx equals 0. This is the quadratic equation now. We are given of this gx equals 0, alpha, beta be the roots. This gx equals 0 means this one, its roots are alpha, beta. Right? Then we can write, people, sum of the roots and product of the roots. Sum of the roots going to be minus q, product of the roots going to be r. Right? Okay. Show that if alpha, if beta, people, if alpha mean, people, now fx is this, fx is this, then if alpha mean, substitute for this x alpha, then we get f alpha. If you substitute alpha for this x in the left hand side, on the right hand side for every x, we have to put alpha. Then we get f alpha equals alpha squared plus b alpha plus c. If beta mean, people, if beta mean, people, substitute for this x beta, then we get beta squared plus b beta plus c. Right? For every x, we have to put beta. If beta squared plus b beta plus c. Now people are asking to find this f alpha f beta product. F alpha f beta product. All right. So then we have to multiply this f alpha and f beta. We have to multiply this f alpha and f beta. F alpha is this alpha squared plus b alpha plus c times beta squared plus b beta plus c. Right. Now, people, you have to remove the brackets by using this alpha squared This three terms you have to multiply. By using this B alpha, these three terms you have to multiply. By using this C, these three terms you have to multiply. Okay, right now. Then what do you get? Alpha squared, beta squared. What is that, people? Alpha beta perfect squared. Now this and this B alpha squared beta, and this and this alpha squared C, right? And this, what do you get? B alpha beta squared, B alpha beta squared, and this two, B and B squared alpha beta, and this B C alpha, right? And next one, by this C multiply. What do you get, people? C beta squared, and C B beta, BC beta, BC beta, and plus C squared. This is what we get. Okay. People, this alpha beta product is this R. Put R for this. Right. And here, this and this. Right. You can see B is common, alpha beta product common. Then we take B alpha beta. We take out. Then here we have alpha, plus here we have beta. Right. And this and this, when you take, you can take, people, C out. C times alpha squared plus beta squared. Right. This we substituted for this. What are other terms? Here, B squared alpha beta. People, what is alpha beta? R. And here, BC alpha and BC beta. When you take BC out, alpha plus beta. And here, plus C squared. This. Right. Now, people, you have to substitute for alpha beta product and alpha plus beta. And this alpha squared plus beta squared, you can write alpha plus beta perfect squared minus 2 alpha beta. Right? Yeah. And then substitute for alpha plus beta and alpha beta again. And simplifying this, try to get this answer, people. I think everybody can take this answer. Right. Now we have R squared plus B alpha beta. Alpha beta is R. Alpha plus beta minus Q plus C times alpha plus beta perfect squared. Here minus Q squared minus 2 times alpha beta R. Right. B squared R plus BC alpha plus beta minus Q plus C squared. Right. This is what we get, people. Now we'll simplify this little bit. Yeah. Okay. Now here we have R squared plus and minus BRQ here minus Q perfect squared is Q squared. This is CQ squared minus 2CR plus B squared R plus and minus BCQ plus C squared. Now people, I take this term, right? This term together. We take them together. Then I can write them together like this. C squared minus 2CR plus R squared. These three I wrote together. People, you know, this is nothing but C minus R perfect squared. Okay, right. And another four terms we have: minus BRQ plus CQ squared plus B squared R minus BCQ, like this, minus BCQ. Right here, people, C squared minus 2CR plus R squared, it is perfect squared of C minus R, right? So then we can write this one as what? C minus R perfect squared. Right. Okay, now the next part we have to take. Right, people. By these two terms, we can take Q out. We can take Q out. Once you take Q out, this is CQ. Here minus BR. People, by this two terms, we can take minus sin and B. Take minus B out. Minus B out, when you take, we get CQ. Here, when you take minus B out, here minus BR. CQ minus BR coming from there too. Then you can very clearly understand, people, when you consider these two terms, this CQ minus BR here, CQ minus BR here, common. You can take that out. Then we get CQ minus BR out. Then this is Q minus B. Q minus B. Right. People, now what I do is this. From this bracket, I take minus sign out. Once you take minus sign out, this order will be B minus Q. That minus sign here and this we can multiply. We get minus here. Then we get C minus R perfect squared minus this one I write B minus Q before, and here it is now CQ minus BR. So this is how we take that answer for F alpha F beta product. F alpha F beta product. Okay, like this we get. Right. Right, people. Now this answer we got. Right now, who could get this answer, people? Yeah, people, this simplification is a little bit long. Inshallah, got good. But people, remember, this is a past paper question. But this question, similar question was in the past paper. Right. This kind of simplification, people, usually we expect in the question. Right. So therefore, expect this kind of simplification. If you find a bit difficult in understanding these people, best thing is do the question from the beginning, again and again. Right. Okay, next one. Next one given people like this. Hence or otherwise, prove that if fx equals 0 and gx equals 0 have a common root. Right. Now people, fx equals 0. Fx equals 0 means fx is this, no? Fx equals 0 mean x squared plus bx plus c equals 0. Right. Right. So then people, gx equals 0 is this. Gx equals 0 is this. Its roots are alpha, beta. Fx equals 0 is this. Right. Now we are given people this equation and this equation have a common root. We are given. People, these two equations have a common root mean, since this has the roots alpha, beta, for this and this to have a common root, definitely this equation should have one of these two roots as a root. Understand? Now, if this equation suppose have a one root alpha, other one is delta, then of this equation one root alpha, this equation one root alpha, this and this have a common root. Or if this equation has one root as beta, other one is delta, again this and this equations people have a common root. So therefore, in order to have this equation and this equation a common root, definitely this equation should have a root either alpha or beta. If this have a root either alpha or beta people, then this and this will have a common root. Correct, no people? Right? Then we can write like this, the next one. Write down like this. When fx equals 0 and gx equals 0, write down like this. When fx equals 0 and gx equals 0, have a common root, this root should be either alpha or beta. Should be either alpha or beta. Right. People, now common root should be either alpha or beta. Then suppose the common root is alpha. Then people, this equation and this equation, common root alpha. Therefore, alpha is a root of this. Then when you put alpha for this x, alpha squared plus b alpha plus c should be equal to 0. Understand? Alpha squared plus b alpha plus c means this. Alpha squared plus b alpha plus c means this. That should be equal to 0. If this is 0, mean people, if alpha equals 0. Understand? Similarly, if beta is the common root for this equation and this equation, beta is the common root, then that beta should satisfy this equation. Beta squared plus b beta plus c equals 0. Beta squared plus b beta plus c mean people, this beta squared plus b beta plus c means this. This equals 0. If beta is a common root, that means if beta is equal to 0. Is it clear, people? Right? Then you can write like this. Write down. If alpha is the common root, then what can say people? If alpha becomes 0. Why? Alpha is the common root means alpha should satisfy this equation. Alpha squared plus b alpha plus c equals 0. That means this one equals 0. Then if people, beta is the common root. Now you can write if beta is the common root, then if beta equals 0, if beta equals 0, if beta equals 0. Then people, if alpha 0 occurs, or if not, f beta should be 0. One of these two should be 0. Why? Definitely, when this and this have a common root, that common root should be either alpha or beta. No. If alpha is common root, alpha 0. If beta is common root, f beta 0. One of these two becomes 0, people. When gx equals 0 and fx equals 0, have a common root. Understand? Then you can write like this. And therefore, when fx equals 0 and gx equals 0, have a common root, either if alpha 0 or if beta 0. Either if alpha 0 or if beta 0. And therefore, people, you can write, therefore, if alpha into if beta product 0, no? This 0 or this 0, one of these two definitely should be 0, people. Either this 0, if this is not 0, then this must be 0. One of that two, definitely 0. That means, people, if alpha or if beta, one of these two definitely 0. If one of these two is 0, mean, people, this product is equal to 0. If alpha, if beta 0. If this is not 0, this is 0. Then this into 0 is product 0. Like that. But if alpha, if beta 0 means, people, we obtain one answer for this if alpha, if beta earlier. Put that here. Then we get what? Right. Right. So then we get if alpha, if beta 0 mean, people, we can write if alpha, if beta means c minus r perfect squared minus b minus q cq minus br is equal to 0. I substituted for this if alpha, if beta, the answer we found, people. Then what we get? We get c minus r perfect squared, takes right hand side, b minus q, cq minus br. Right. Okay. Now what is asking, people? If alpha, if x equals 0 and gx equals 0 have a common root, then b minus q, c minus r, cq minus br are in geometric progression. What is meant by, people, geometric progression? Right? Geometric progression you learned in your levels, right? Geometric progression means this. First term 3, common ratio 2. When we write a geometric progression, how to write, people? 3 first term. To get the second term, this 3 should be multiplied by the common ratio 2, we get 6. By that, we have multiplied again by 2, we get 12. Multiply this by 2, we get next one 24, next one 48. Right, people? Like that, 3 first term, multiply first term by the common ratio, we get the second one. second term. Second one multiplied by the common ratio, we get third term. And so on, we can generate a progression. That progression only people we define as what? Geometry progression. When you consider any three consecutive terms, any three adjacent terms, when you consider, when the three terms lie in a geometry progression, people, there's a common property. That common property is, people, when you square the middle one, right, it is equal to the product of the other two. See here, when you square the middle one, it is equal to product of the other two, right? Then people, if we can show perfect square of something is equal to product of another two things, then coming this in the middle of these two, 3, 6, 12, these three terms lie in a geometry progression. Right? Then here also you can see here, perfect square of this. Perfect square of this is equal to product of this and this. Then without the square, coming this C minus R in the middle of these two, B minus Q, and this C minus R and CQ minus BR should lie in a geometric progression. So clear, people, right? In a geometric progression, right? Then we can write it like this. People no need to explain this thing kind of what story, because by the observation we can see perfect square of this is equal to product of these two mean, people, right? Coming without the square, this C minus R in the middle of these two, in that order, the three terms will lie in a geometric progression. Then you can write this implies B minus Q times C minus R times CQ minus BR lie in a geometric progression. So that is how we take that answer. Okay, people, now next one. People, read the last part of that. Right. Read the last part of that. I'll give you 2 minutes. Yeah. Now we had been given gx equals 0 roots are alpha beta. X squared plus qx plus r equals 0 is the gx equals 0. Its roots are alpha beta. Then we wrote alpha plus beta and alpha beta. Alpha plus beta is minus q. Alpha beta is r. Right. And now we are given, people, next one like this. If alpha and gamma are the roots of fx equals 0. Fx equals 0 mean this is 0, no? X squared plus bx plus c equals 0 is the fx equals 0. Its roots are alpha gamma. Its roots are alpha gamma. Then alpha plus gamma, we can write. Alpha plus gamma going to be, people, minus b divided by x coefficient 1, and alpha gamma is c. Right. Now people asking this, what? Show that the quadratic equation whose roots are beta comma gamma is this. Right? Beta comma gamma is this. Then we know, people, quadratic equation with the roots beta and gamma. How to write? When you are given the two roots, how to write the quadratic equation? We can write the quadratic equation. The equation with the roots beta and gamma. How to write, people? X squared minus beta plus gamma times x plus beta gamma equals 0. Right, people, they are to find this equation, we need beta and gamma. Now our purpose is to find, people, this beta and gamma. Right? Yeah. And then people, This is how I am going to find this beta and gamma, right? Now you can see this equation, right, has two roots alpha beta. This equation has the roots alpha gamma. Then you can see this equation and this equation, they have a common root. What is the common root? Alpha, right? Then you can see what people. First thing is this. Since alpha is the common root, then alpha should satisfy this equation as well as this equation, people. What do you get? Put alpha for this x, alpha squared plus q alpha plus r equals 0. And what is the next one? Alpha squared plus b alpha plus c equals 0. Take this as 1, this as 2. People take 1 minus 2. 1 minus 2. Where to 1 minus 2, people, you get alpha squared and alpha squared, you can cancel down. Correct, no, people? And when you subtract this from this, what do you get? Q alpha minus B alpha. And R minus C equals 0. Take this alpha out. Q minus B. Take this right hand side. C minus R. Then we get alpha, people, C minus R divided by Q minus B. Right? That is the common root. Now our purpose is to find, people, beta and gamma, no? Then beta and gamma you can find like this. Here, alpha beta product is R. Alpha beta product is, people, R. Alpha is known here. Then we can find beta. Now you can write, since alpha beta equals R. Substitute for this alpha, this answer, people. C minus R divided by Q minus B times beta equals R. Okay. Use the cross multiplication like this and like this. Then you get beta. It's beta. You can write R times Q minus B divided by C minus R. Right? And by this alpha gamma, see. Since alpha gamma is C, I can substitute for alpha, C minus R divided by Q minus B times gamma is C. Gamma, people, use this C. C times Q minus B divided by C minus R. Okay. Then we know, people, this beta we know, this gamma we know. Then we can write by this equation. Then you have to start like this. The equation with the roots beta and gamma, this, put that as star. Now, since alpha is the common root, then that alpha should satisfy this equation as well as this equation, right? Then we took these two equations and we subtracted, thereby we found this alpha, the common root. Putting that alpha, where here we found this beta, arms of beta is this. Putting that alpha, where here we found this gamma, people, arms is gamma is this. Then we know both this beta and gamma. Now we can write the equation, right, with the roots beta and gamma, right? Then you can write, therefore, by star. Star is this, no? What is that star? The equation with the roots beta and gamma, right, people? Then substitute that beta gamma answers we are here. We get what? X squared minus, what is beta? R times Q minus B divided by C minus R plus gamma C times Q minus B divided by C minus R. X plus beta gamma product, that time this R times Q minus B divided by C minus R into this C Q minus B divided by C minus R equals 0. Equals 0, right? Now we can take this answer. Right, now we can take Q minus B out. Take this Q minus B out. Then once you take Q minus B out, we get C plus R or R plus C, no? C plus R divided by this C minus R times X. And here people R and this C make CR. Q minus B into Q minus B mean people Q minus B perfect squared divided by C minus R perfect squared equals 0. This is how we get that answer, right now people? Okay. Okay then.